You know, we've all seen the mushroom clouds in the movies, but what happens when you take that same unbelievable power and set it off where there's no ground to shake and no air to blast? What if a nuclear bomb exploded in the complete silence of outer space? Right off the bat, you've got to throw out everything you think you know. See, on Earth, a nuke's real destructive power is that massive blast wave, a superheated wall of air moving faster than sound. But in space, well, there's no air. So instead of a physical blast, you get something different, something way more sinister. A silent, invisible wave of pure radiation.
So, yeah, let's dive into this different kind of bang. We really need to understand how all that raw energy behaves when it's released into the vacuum of space, with absolutely nothing to physically push against.
It's such a simple fact, but it changes everything. With no atmosphere, all the classic signs of a nuclear explosion just can't happen. There's nothing to carry a shockwave, no air molecules to ignite and churn into that iconic mushroom cloud, and, maybe the eeriest part, no sound at all, just silence.
So, where does all that incredible energy go? Well, instead of a blast, a staggering 70 to 80% of it is instantly converted into a massive, invisible pulse of X-ray radiation. The bomb basically becomes a high-energy particle cannon. And that's the key takeaway here. In space, the weapon isn't physical force, it's pure, weaponized energy. And this flood of radiation is exactly what creates the most famous and feared effect of a high-altitude detonation. We are talking about the silent weapon, the electromagnetic pulse, or as you probably know it, EMP.
An EMP is pretty much what it sounds like, a huge, instantaneous burst of electromagnetic energy. It won't knock down buildings, but it can disrupt, fry, or just permanently destroy any unshielded electronics over an entire continent. Think of it like a lightning strike happening everywhere, all at once.
Okay, so how does this actually work? It happens in 3 quick steps. First, gamma rays from the explosion shoot down and just slam into the top of our atmosphere. Second, those powerful rays knock electrons loose from air molecules. This is a process called the Compton effect. And third, our planet's own magnetic field grabs these new, super-energized electrons and forces them to spiral downward, creating this gigantic, sweeping electrical current. That current is the EMP.
But the EMP isn't even the whole story. The early nuclear tests revealed something else, something totally unexpected and, frankly, terrifying. We accidentally discovered how to create an artificial death trap in the sky using Earth's own magnetic field against us.
So the same magnetic field that creates the EMP also acts like a net, trapping charged particles from the nuclear fireball. This creates these man-made radiation belts. And here's the long-term danger. These belts don't just fade away in a few hours. Oh no, they can linger for months or even years, acting like persistent invisible minefields for any satellite that dares to pass through, slowly frying their electronics and destroying their solar panels.
Now, I know this all sounds like something out of science fiction, right? But it's not just theory. We know all of this because, well, we've actually done it. Let's talk about the most famous example, the Starfish Prime experiment. This is the moment all this physics became a terrifying reality. So on July 9, 1962, the United States detonated a 1.4 megaton warhead about 400 kilometers up, that's 250 miles, right on the edge of space. To give you some perspective, this one bomb was about 100 times more powerful than the one dropped on Hiroshima. And the results were way more dramatic than anyone had predicted. You had these stunning, totally artificial auroras that lit up the sky across the Pacific. But on the ground, things were a bit more sinister. The EMP was so strong it blew out streetlights and set off burglar alarms in Hawaii, nearly 1,500 kilometers away. And up in orbit, at least 6 satellites were either damaged or completely destroyed by the artificial radiation belt that formed, a belt that stuck around for months. And that brings us to the most important part of all this, which is our fragile sky. I mean, why does an experiment from over 60 years ago matter so much more today than it did back then? So let's just ask that question. In our world today, a world that is completely, totally dependent on this fragile web of technology orbiting above us, what would happen if a Starfish Prime event happened right now? It would be absolutely catastrophic. See, back in 1962, there were just a handful of satellites up there. Today, there are thousands, and they are the literal backbone of modern civilization. A single detonation could kick off a chain reaction of failures.
GPS, which controls everything from your phone's map to global financial transactions, could just go dark. Global communications would fail. We'd lose critical weather satellites. The economic damage would be almost impossible to even calculate.
You know, the terrifying results from tests like Starfish Prime are what directly led to the 1967 Outer Space Treaty, which banned putting nuclear weapons in orbit. The world figured out pretty early on that the very infrastructure of our modern world is orbiting right up there with any potential weapon. It's a sobering thought, isn't it? The same invisible shield that protects our planet, our magnetic field, is also the very thing that can turn a nuclear explosion into a silent, continent-spanning weapon.